For this lesson, we're going to need to know what diagonals are, or what a diagonal is. And a diagonal is a line segment connecting any two non-adjacent vertices, meaning not right next to each other. It's also going to be helpful in this lesson to be able to sketch pretty well. So let's start with a rectangle looking shape. We're going to make this one 8 meters and 12 meters. So first of all, sketch the diagonal. And does it really matter which one? Probably not. I'm going to do that one. So what would the length of the diagonal be? Well, hopefully you're recognizing if this is a rectangle, that angle must be 90 degrees. This is a right triangle. So d squared is going to equal 8 squared plus 12 squared. So the diagonal squared will be 64 plus 144. And d equals the square root of, notice I kind of did 2 steps in one, 208. I know that's a little bit more than 14 because 14 squared is 169. So I'm going to guess about 14.3, and then I'm going to go check that on my calculator. My calculator says 14.42, so I was off by a tenth. Not bad, but I'm still practicing. 14.4 units. That would be the length of the diagonal. Well, very quickly, we want to transition to three-dimensional diagonals. So to do this one, it's going to be really fun for us to learn how to do kind of a box, right? So you can start with a rectangle, and then I do 3 parallel same length lines back and to the right, and then I finish those off. And if you like, put in the dashed lines that would indicate the inside. So try to make this same length and slant using dashed lines. Something like that. So what's going to be interesting now is to find the three-dimensional diagonal here. And so the three-dimensional diagonal here will be from any one of the bottom corners to the opposite top corner. So for instance, it would be this corner, front, bottom left, and top right in the back. So that would be one diagonal. And of course, there are 4 diagonals that you could draw, but if I draw or sketch that one, and I'll make it dashed again. How am I going to get that one? Hopefully you see a right triangle again, where we can use the diagonal of the base or the bottom, and then the side length. So that might be getting to be a lot for you, but that's what we need to focus on. So let's give this rectangular box, rectangular prism, some dimensions. How about the front will be 4, the depth will be 3, and this height, I don't know, that's looking pretty tall. Let's give it like 13. Well, the diagonal of the base, can you recognize our Pythagorean triple? It's going to be 5. Because this is a 3, 4, 5 triangle. So now I'm going to use 5 and 13 to get my three-dimensional diagonal. So again, d squared equals 5 squared plus 13 squared. So 25 plus 169, 194. And again, I know that's really close to 14 because that's 196. So square root both sides, and d is approximately 13.9 units. And that's the three-dimensional diagonal. So let's do another one, give you a chance on this one. So if we fill in those dashed lines, let's make the bottom 8, 5, and a height of 6. And this time we're going to go from this corner to this corner. It's a 3-dimensional diagonal. So pause the video, find the 3-dimensional diagonal. Okay, so I am looking for the diagonal of the base and then the height. So I know the height that I'm going to use is 6. But this 3-dimensional diagonal, this one's not so easy. This one is going to be 8 squared plus 5 squared, 64 plus 25 equals the square root of 89, so 9 point something. But you know what? I don't really need to square root it, although I find it's about 9.4, but I don't want to use this rounded decimal because I'm going to be squaring this again in here in a minute. So let's change colors again. So back to the green, which is what I want, the 3-dimensional diagonal squared is going to equal 6 squared plus the square root of 89 squared. So of course, squaring a square root makes it 89. So D is going to equal the square root of 125. And I can see that's barely over 11 because that's 121. So approximately 11.2 units.